Very good morning to all participants. Very good morning to all. Myself Sneha NP, Assistant Professor, Department of Computer Science and Engineering, ATME College of Engineering. With tremendous happiness and gratitude, I take this opportunity to brief about ATME College of Engineering. Spread over 25 acres of green expanse on Bannur Mysore Road, Mysore, ATME College of Engineering has created an ecosystem of teaching, making it a universally accepted place for education, and ATME prides itself in putting the students first. ATME College of Engineering is founded by a group of like-minded technocrats in 2010. Founders are managing various kinds of enterprise like infra companies, manufacturing units, and IT services. Founders are aware of the need of industry and trying to cater to such needs by developing industry-ready engineers through ATME College of Engineering. ATME has created a futuristic infrastructure with 3 lakh square feet of build-up area, state-of-art labs, a cluster of seminar halls and auditorium with all modern gadgets, library, central processing facility, etc. All this has been done with a span of 8 years and can proudly be said that our infrastructure is at par with any institution with a standing of 20 to 25 years. It's not only the infra but also the kind of faculty profile ATME has engaged, teaching learning process adopted, student support system put in place, co-curricular and extracurricular activities being conducted, and placement achieved with this shortest span of time is significant. ATME College is NB accredited and 9001-2015 ISO certified. So Department of Computer Science has taken the first initiative to start with the student branch of Computer Society of India, CSI, a professional body at national level in the year 2012, and all the students in the department were enrolled as student members. The college also obtained the CSI institution membership, and most of the staff members are life members of CSI. Currently, 327 students are members of CSI. Under CSI, we are organizing a webinar on Unlock Your Data with Data Science. On behalf of this, I take this opportunity to welcome our today's speaker, Hemant Kumar A, Data Science Consultant, Rubix Technologies Private Limited, Bangalore, for this webinar. Welcome you, sir.
Thank you very much, madam. Thank you very much.
Now I would like to welcome our beloved principal, Dr. Basavaraj L, who has supported us in all our endeavors. Welcome you, sir. Now I would like to welcome Dr. Puttegowda D, HOD, Department of Computer Science and Engineering, who has been a great support in organizing this webinar. Welcome you, sir. Now I would like to welcome all the participants to this webinar. So now I would like to hand over the session to our today's speaker, Hemant Kumar He. Sir, I would like you to take over the session, sir.
Right, madam. Thanks very much. I once again welcome you all to the session on Unlock Your Data with Data Science.
Thank you, sir.
Thanks for giving me this opportunity. So without wasting our time, let us get started with the session now.
Okay, sir.
Okay.
Okay,
before that, I need some confirmation. Am I audible to you all? Yeah, fine. Okay, thank you. So let us move on to the concept now. Today, I would like to discuss some of the important concepts in data science. I'll start with introduction. I'll also speak about different types of data. The very important part is data science task, and then the Venn diagram of data science. And we'll eventually define what is a data science. And then the very important core part of this webinar is to understand data science workflow. I will also speak about machine learning and machine learning process. And for students or for anybody else who wanted to start this data science career, I'll also give some tips. And lastly, I would like to give some links for learning this data science. Okay, let us get started with the introduction now. Now, we all know that data is everywhere, isn't it? Data could be a facts, images, audios, videos recorded and stored, generally speaking. Data could be anywhere means what? You go to any e-commerce websites, you wanted to purchase any product, we are all giving our data, right? And Flipkart or Amazon, e-commerce kind of websites are actually collecting your data. You go to any department websites, you are swiping your cards, you are actually giving your data, isn't it? You make so many banking transactions, you are giving some data. It could be the sensor data, the IoT data, or social network data. We are very much active nowadays on social network. That could be on WhatsApp, could be on Instagram, Facebook, Twitter. We usually upload images, audio, videos, different kinds of images, audios, videos. So that can be considered as a data. When you say data is everywhere, now what you do actually with this huge amount of data? The next question is, what are you actually going to do with this huge amount of data? Okay, let us go a little in depth of this data and we'll see what are the different types of data. Normally on the top, we say that we have three types of data at a very high level: structured data, semi-structured data, unstructured data. Okay, so let us see one by one now. Now coming to this part, you people have learned this database data, which is a structured query language, isn't it? So which is a relational databases, a table-like form. We store some numerical data and textual data in that particular databases. That data particularly fits into this database data, which we usually refer to as relational databases. And we usually make use of this structured query language in order to process that data, isn't it? So that is one of the example for structured data, because data you are storing fits perfectly in the relational database management system. Okay. These are some of the examples for data. We have some numerics, we have some text. So that goes into your RDBMS. Okay. Now coming to the opposite part, the completely opposite part of this is NoSQL data, not an SQL data, which does not fit in the relation databases. Okay. Now, what is the data which does not fit in the relational databases? Okay. Now, that could be the images, the audio files, different kinds of audio files, different kinds of video formats, the GIF files. So that is, you can consider as example for unstructured data. Normally, when you try to upload any videos, audios onto your social media network, we usually upload this unstructured data. Now, how these people are actually storing this unstructured data? That is a very biggest question. They use not an SQL database management system. Taking an example for that, Cassandra is one example where we have a key and the value pair. You have an image and there is a key for that. You have a video, there is a key for that. Okay, so Cassandra, MongoDB are some of the examples for this unstructured data. Okay, so now in between these two, there is something called as semi-structured data. If you work on this JavaScript object notation, there is something called as JSON, which also includes some tags, which also includes some values with that. It means that it is an unstructured, semi-structured data. JSON is one example for semi-structured data, which comes in between this structured and unstructured data. Also, if you worked with this XML, extended markup language, just to carry information from client to server, we make use of this XML. We have this, semi-structured data. At a very high level, we say that we have these different kinds of data that could be structured, semi-structured, unstructured. Whatever the data formats you are dealing with, the main agenda or the main intention in data science is to grab the insights out of all this data. Okay, mostly we are going to deal with this structured data now. Okay, now coming to this part, task in data science, which is one of the important concepts that everybody has to remember. For all the data science aspirants, I say that this is where the interview questions starts. Okay, data science is having close relationship between this statistics, mathematics, and then machine learning algorithm. We also see that in future. But coming to this part, we have different kinds of tasks in data science. The first one is predictive analytics, descriptive task. Okay. Now, what is this descriptive task? Now, you have this huge amount of data, as I told you that can be considered as a big data. When you have this huge amount of data, then you may come up with some visual representation. Okay. And you see that by observing that visual representation, you'll get to know some, finding. Now, on your left side of your slide, I've taken this COVID-19 data since past 15 days. We have this COVID-19 data set. Some patients, active deaths, active cases, recoveries. As you can see in this graph, this is a stacked bar plot. I'm trying to plot the number of deaths, recoveries, and the active cases. It means what? We have this data, okay? You're coming up with some visual representation, okay? Maybe by summarizing the data, and you are actually finding the insights of the data. As you can see in this graph, in the last 15 days, deaths, recoveries, and active cases are increasing as the number of days are also increasing. We are really bugged off about this, COVID-19. But anyhow, I would like to take some COVID-19 examples here in this webinar. Okay. Now, take an example in a layman terms, in a very simple example. Descriptive task always tells you that what has happened. It means that you have the past data, you are coming up with some visual representation, could be in any graphical formats, and you're saying that what has happened. Taking an example of COVID-19 in a healthcare setting, for instance, say that an unusually high number of people are admitted to the emergency room in a short period of time. Descriptive analytics tells you that this is happening and provides real-time data with all the corresponding statistics. Could be the volume of patients and the patient details. And let's say that if you are doing this job or a task, then you are said to be data analyst because you are only coming up with some visual representation. Okay, so this is something referred to as what? Descriptive task. The very first task in data science. Okay, coming to this, going further, we have something called as diagnostic analytics. It says that why it happened. You started thinking that you see some sudden rise in COVID-19 patients, there are more number of active patients, there are more number of deaths, and you start thinking about it, you start diagnosing the things, why it all happening. Okay, we know that this virus has come from Wuhan, the city in China, and then it is getting spread all over the world. That's fine. Now, we make use of some tools, data mining tools, data discovery tools, okay, in order to diagnose the things, why all this are actually happening. Okay. Now, if you are actually answering this question, why it is happening, then you are actually performing what? Diagnostic analytics. We have some of the tools like Power BI and then Tableau, which will help us to let us understand why these things are actually happening, which is something referred to as diagnostic analytics. In a very simple term, why it happened. This is a second important task in data science. Okay. In healthcare example, as we took an example here, would explore the data and make correlations. For instance, it may help you to determine that all of the patient symptoms. Now, the COVID-19 infections is spreading like anything, and you also try to identify what are the symptoms in those COVID-19 patients. That could be high fever, dry cough, and the fatigue. Okay, you try to diagnose the things, and therefore we say that this is diagnostic analytics. Okay, this is the second task in data science. Now, come to the next very important task. We are very much interested in this predictive analytics. Okay, we are done with this descriptive and diagnostic. We answered what has happened, why it happened, and now it is to answer what will happen in the future. This is a very important thing that everybody has to remember here. We are going to integrate this computer algorithms, something called as machine learning algorithms, to say what will happen in the future. Okay, so this is a point we are very much interested in. So predictive analytics is all about that, what will happen. Okay, so it means that back to our COVID-19 example. Okay, predictive analytics may forecast a surge in patients admitted to the emergency room in the next several weeks. You see, maybe in the month of July, the number of patients are increasing. In the August, you may see even more number of patients. Maybe in the month of September, the curve might get flattened. We'll have to predict what's going to happen in the future. How do you predict what's going to happen in the future? That is where the machine learning algorithm comes into picture. It is not that you only have the data, but still, you should also remember that you're trying to bring this machine learning in this context. Okay. Now, you see so many patients admitted in the emergency room in the next several weeks. Based on the patterns in the data, the illness is spreading at a rapid rate. Yes, we see that the illness is spreading at a rapid rate. Now it is a community spread, isn't it? It means that use some machine learning algorithms, try to say what will happen in the future. Now, if you're doing this job, which is predictive analytics, using some machine learning algorithms, using some statistical tools, and then having some mathematical knowledge, then you're said to be data scientist. Remember that initially I told you that if you're doing this descriptive task, you're only said to be what? Data analyst. But here in this case, we call you as a data scientist, having a skills of machine learning, which is very important. Okay. Now, the very last thing is I've taken one example here. As you can see in this here, on the x-axis I've taken time since first case. On the y-axis I've taken number of cases. As you can see here, as the time goes, hopefully the curve is actually getting flattening the curve. Okay, maybe in the month of July or August, you see more number of patients, and as the time goes on the x-axis, the curve is also getting flattened. So this is something we do it using this predictive analytics. Okay, using some machine learning algorithm. I'll take that point in the later slides. Enough. Now, the very important task, the next task after this predictive analytics is prescriptive task. Now, in a very simple term, what can I do? So we answered what happened, why it all happened, and what will happen. Now, after doing all this, you'll have to answer what can I do? You'll have to come up with some solution. It always recommends actions you can take to affect those outcomes, isn't it? Now we'll have to give some suggestions. The illness is actually spreading like anything. You may have to arrive at some solutions saying that you'll have to extend this lockdown period. Okay, that may be the solution you get. Maybe you'll have to increase the number of the healthcare workers. Maybe you should not allow this, patients to roam around the city. You may require high number of policemen in the city to control all this, people roaming around the city. And then the number of doctors should also get increased. And maybe the number of beds in the hospital should also get increased. It means that prescriptive task also always gives you some recommendation, says that it will always recommend some action that you can take to affect those outcomes. So it is all about what can we do. That's it. So after doing all this task, we are at a last stage, which is something called as prescriptive task, which is one of the core concept in what? Data science. We are done with all the tasks in the data science. Slowly we'll jump into this next concept, which is data science Venn diagram. Remember that as a data science scientist, you will have to have some programming skills, mathematics and statistics skills, and the communication skills. What do you mean by this communication skills? Communications could be orally speaking or verbally writing. Okay. So all this, skills you must have to become what? Data scientist. Now coming to this part. Now let's say that you have this maths and statistics skills, because sometimes we deal with this statistical concept. Okay. And also we have this mathematical concept in this data science. Let's say that you have this mathematics and statistical skills, and also you have this communication skills. Now in the previous slides, I told you that in the prescriptive task, you're recommending some action. It means that either by communicating with your higher ups or by giving some description, you're saying that, okay, this is what you'll have to do it, isn't it? So if you're having these two skills, maths and stats and communication skills, then you might be called as a researcher with some domain experts. Okay, you have some domain expertise, okay, having this maths and stats skills, and then you also have this communication skills, but you doesn't have this programming skills. You may have some really good domain knowledge. You may come up with some research papers and etc. Okay. So if this is a case, maybe you are said to be a researcher with some domain experts. Okay. Now coming to the next point. Next is programming skills. Let's say that the other part, this part, you have this programming and you also have this communication skills. We are not speaking about this maths and stat skills now. If that is the case, you are said to be the ML engineer. Okay, machine learning engineer, because you also have this programming skills. You may be well versed with this programming skills like Python programming language or R programming language or Scala or Julia, etc. You're said to be what? The ML engineer. But it doesn't have this maths and the stat skills. Remember that if you have these skills, only 2 skills, you are in a danger zone. Remember, you are in a danger zone. Why I'm calling this zone as a danger zone? That is the point. Remember that you may be well versed with this programming and communication skills, but you do not know what's actually the mathematics or statistics behind this programming skills. If that is the case, you fail to become a data scientist, a complete data scientist. See, nowadays we have so many packages available, could be in any languages. You simply drag and drop it, import it, and then you start programming. That's possible even by a 10th standard student, high school student. But what we want is that whenever you start with any problem, you should have all these skills: programming, communication, maths and stat skills. Then you are said to be a data science expert. Getting my point? If you understand this data science Venn diagram, then you become what? The complete data scientist. You should have this programming skills, maths and statistical skills, and then the communication skills. If you're missing any one of this, you're in a danger zone, I tell you. Okay, so this is again a very important thing that everybody has to remember, because some may go with straight away with this programming and then they're really bored of learning this maths and stat skills. They're not even touch this maths and stat skills, and then if you're doing that, you cannot become a data scientist. Remember that. Okay, so this is a one Venn diagram that everybody has to keep in their mind in order to start with this data science career. Okay, now coming to this point, so we learned what are the different tasks in data science, and then the data science Venn diagram. Now it is the time to define what is a data science. Now, what is a data science? Okay, data science, using data to make decisions. In all the previous tasks, we did some analysis. We made some descriptive analytics, diagnostic analytics, predictive analytics, prescriptive analytics. In all that analysis, we said that after doing that, we actually took some decisions. Probably doing this predictive analytics, what will happen in the future, or prescriptive analytics, we said that okay, you will have to increase the number of health workers to handle this influx of more number of patients. It means that using data to make decisions, in a very simple term, data science is all about. Okay, now let us try to elaborate it much more. We say that data science, as we just went through this Venn diagram, it is a combination of statistics, machine learning, data analysis, and other related methods that everybody has to remember. It is not only that the ML, it is not only that maths and statistics skills, it is not only that the communication skills, but it unifies the statistics, machine learning, data analysis, and other related methods. Okay, this is how we define data science. If somebody asks you the internet, what is it in the interview, what is the data science? Okay, in a very simple term, you can say that data science is all about using data to make some decisions. To further go in depth, we say that it unifies statistics, machine learning, and data analysis, and other related methods like could be the linear algebra. Okay, so this is all about what? Data science. Okay, now coming to this very important job here, data science workflow. Now, what is this data science workflow here? So as I told you that this is where the actual data science problem starts. Let me take a very simple example. We have 5 steps here, as you can see. You should always start with a question. Remember that. You should always have a question in your mind. Okay. Then after having this question, you should always get the data. Maybe you perform data pre-processing job, and then perform some EDA, what we call it as exploratory data analysis, and then you try to apply some techniques. I'll tell you what is all about these techniques, okay? And then you start sharing the insights after performing all these 4 steps. Now coming to this first task, start with the question now. What is the question I've taken here? If I study more, will I get a high grade? Very simple question I've taken. So it could be a very simple questions or a very complicated questions. To understand this data science in a very simple manner, I've taken this first question which says that if I study more, will I get a high grade? Generally speaking that, okay, if you study more, you'll definitely get a high grade. Now, what we do is that I'll approach my academician and I'll try to ask him that I want all his students' records, databases. I'll take all those records, okay? Let's say that the professor or the academician has given me this data. As you can see in this data, he has given me this data. So there are certain students here, very sample data I've taken here, number of hours studied, and the grade that particular student has obtained, okay? So we have how many students here? 1, 2, 3, 4, 5, total 7 students are there. Hemant is studying for 20 hours in a week and is getting a grade of 90. Vivek 5 hours, 70. Others 10 hours, 96. And then Avinash 15, 82. Shruti 2. I think you can see all the numbers are in numerical format, whereas this is in categorical 1. 2, 62. Priyanka 16 hours in a week. She is scoring 87. Prasanna 22, and then he's scoring 990. How it is possible to score 998? It is highly impossible to score 998, right? So we're in the second step. We are done with the first one, which is if I study more, will I get a high grade? So after collecting this data, we have, start observing this data, and we got to see that, okay, there are some, mistakes in this data. Some correction has to be made. So that is where we look into the process of data pre-processing. Remember that. So once you have this data, it is not that you can straight away go ahead with the analysis part. You should always look into this data pre-processing job. It means that all the numbers are in numerical, okay, numerical format, whereas this is in the categorical one, and this is going beyond our expectation, which is 998. So this has to be eliminated. How do you eliminate this? You'll have to perform some data pre-processing programmatically. Okay. Now I'll try to remove this. Okay, let me replace with 2 with 2, 998 with 98. Now, okay, Shruti, she's studying for 2 hours a week and she's getting a grade of 62. Prasanna is studying for 22 hours in a week and is getting 98. That's fine. You're done with the second step. You're done with getting the data and cleaning the data. That's fine. You're done with the second job. You're happy now, right? Now it is the time to go with the process called EDA. Okay, this is where the people actually fails. See, one which doesn't have this skills in this EDA, you will fail in becoming a data scientist. Remember that. This is something referred to as exploratory data analysis. You'll have to come up with some analysis part, maybe in the form of graphical representation. Okay, you may use some different graphs depending on the kind of data you're using. Okay, which is all related to statistics. Okay, now we are into this third one, which is perform EDA. Let me try to plot a graph for this. I'll consider this scatter plot, which is very relevant for this numerical data. Okay, as you can see in this x-axis, we have this hour studied, and we have this y-axis, which is grade. Okay, I've plotted all this number of hours studied and the grade that a student has obtained. As you can see here, okay, somebody is studying for 2 hours, which is Shruti. She's getting around 62 marks. Somebody is studying for some, what is it? Some hours, like 3 hours, and then is getting some 72 marks, 10 hours, 6 hours, and then somebody studying for 22 hours is getting 98 marks. Somebody studying for 10 hours is getting 96 marks. So all the students are studying, they're working really hard, okay? In a week, they're studying different number of hours and they're getting this grade. So this is how we say it as exploratory data analysis after plotting a graph. Now, after plotting this graph, what we actually obtained from this graph, something referred to as finding. Okay, so now we'll see that first finding now. Finding 1. Okay, we see that we will have to take one key term here, something called as correlation. Correlation means what? How the two variables are actually going together. Co means together and then related. whether this variable is associated with other variable, whether it is not associated with the other variable. Okay, we have taken two variables here, the hour study and the grade. So what we are trying to say here, the finding one is the more you study, the higher grade you will get. Obviously, the more you study, the higher grade you will get. It means that there is some positive correlation between these two variables after plotting this graph. Also remember that after observing this data in depth little more, I also found out that Adarsh, as you can see in the data set, who is Adarsh here? Yes, Adarsh is studying for 10 hours. Is actually getting a grade of 96. Now, what does it mean actually? So that is my finding too. I'll have to identify that something which looks different for me in this EDA after doing this EDA, which is Adarsh is a smarty pants because he's studying for 10 hours and he's getting 96 marks, whereas this Prasanna who is studying for 22 hours is getting 98 marks. A student who is studying for 10 hours is getting 98 marks, 96 marks. And then we're spending 22 hours in a week is getting 98 marks. It means what? Others is a smarty pants. Okay, this is the finding that I've obtained. Anyhow, we'll keep it aside now. You're done with what? EDA, which is something referred to as exploratory data analysis. Okay. Now, we go to the fourth step. This is a very important task that everybody has to remember, applying some techniques. What is that applying some techniques here? Okay, we'll try to apply some techniques now. Okay, which says that apply machine learning algorithm and share insights. So we're trying to bring this fourth and fifth step here, which happens to be you need to apply this machine learning algorithm. Okay, we haven't applied any machine learning algorithm, and then you'll have to share the insight. Okay, now we'll have to look into this fourth step, which is again a very important one. Now slowly, assume that we are done with all the three steps. Now we are in the fourth step. We'll have to look into the concept of machine learning. We are in the stage of predictive analytics. Remember, predictive analytics plays a very important role because we're making use of some machine learning algorithm now. And then we'll see the fifth step, which happens to be the share insight. Okay. Now, slowly, I wanted to tell you something about this machine learning, the fourth step. Assume that we are still in the fourth step, because we'll look into the concept of this machine learning and then we'll try to apply some algorithm and then we'll try to share the insight. Okay, I think you'll have to bear with me for another 1.5 hours. Okay. Now coming to this fourth step, apply techniques. I do not want directly go and start away applying these techniques. Remember that machine learning plays a very important role in the predictive analytics. Okay. Now what is a machine learning? Machine learning is a study of computer algorithms that improve automatically through experience. It is seen as a subset of artificial intelligence. As you can see in this figure, so we have a computer science here. We have data mining. As the technology has evolved, we started defining terms in different terminologies. We said that machine learning, we are trying to integrate this machine learning. We also said that, okay, so in a broader perspective, we also have this AI, okay, machine learning and data mining is again a subset of this AI. And then we have a data science at a very high level, which combines all this thing. Now coming to this machine learning, we say that it is study of computer algorithms that automatically runs through experiences. What do you mean by learning through experiences? Experience is nothing but the data. Remember, I'm saying it as an experience, but in the context of data science or machine learning or AI, you should always remember that experience is nothing but data. You should always have this data, okay, give it to an algorithm or feed it to an algorithm. That algorithm, the specialized algorithm, starts learning by itself. Taking a very simple example, it is something like how we human learns through experience. Let's assume that, let us take a very simple example, analogy, that when some time ago I was going in my car above 100 kilometers speed, and then I experienced a very bad situation. I met with an accident. Okay, I've learned through my experience I should not go above 100 kilometers speed. Okay, and later in the future I started going by the speed of 60 or 70 kilometers. It means that we humans learn through experiences, isn't it? Okay, we have seen it, we are doing it, and we are experiencing it. In the same way, this machine learning algorithms also learns through experiences. It means that the input to the machine learning algorithms should be always your data. As we took an example that the number of hours you study, the grade you get can be taken as some, what is it? The data for your algorithm. And you can start doing this, machine learning task or apply this fourth step. Okay, this is all about this machine learning, study of computer algorithms that will automatically learn through experiences. You should always remember that learning through experience, nothing but learning through data. Okay, now coming to this part now. Before we actually try to apply any techniques, we will have to know the different types of machine learning. Different types of machine learning. Coming to this part, I've taken only two parts here, two categories. One is supervised ML, also called as predictive task, okay, and then unsupervised ML, which is also said to be descriptive task. As you can see here, do not get always confused with all these terminologies. So in the context of data science at a very high level, we said that it is descriptive task, whereas in this machine learning, we say it as unsupervised learning. Whereas in this, data science level, we said that it is a predictive task. In the machine learning context, we are saying it as a supervised ML. Let us see one by one now how this actually algorithms or how this technology categories do work. Coming to this left part of your slide, we have this continuous target data, categorical target data. What does it mean actually? Okay, the supervised machine learning again categorized into two parts. One is continuous target data and then categorical target data. Now, what is this target data? Remember, target data is nothing but the output. Remember the example that I had considered. Say, for example, the number of hours you study is a numerical format and the grade you get is again in numerical format. The grade is said to be your output, whereas the number of study is said to be your what? The input. It means that in the supervised learning algorithm, you have a data set which is also having this input, also the output. Getting my point? Okay. You also have this input, you also have this output. This output is nothing but the target data. The grade in that particular data set can be considered as the target data. Okay, in the context of machine learning. In a very simple term, we say that it is output data. Okay. So in the other way, we also call it as the label. So target data is nothing but the output data. Again, based on this continuous target data, you should also always remember that continuous and target data. Continuous means what? As you take an example of this analysis of grade system, all the data is in numerical format, numerical data. Remember that we have a category of algorithms, which is something referred to as regression, okay, which is a part of, again, statistics, okay, which only deals with this numerical data. Okay. And then we have other category, which is classification. Let's take an example that having the customer data, you wanted to predict whether that customer will buy the newly launched iPhone mobile phone or not. Let's take an example that you have the salary of a person, the age of a person, based on the two input variables. You say that what is the likelihood of buying this particular product, which is Apple iPhone, newly launched Apple iPhone mobile phone. Either it is yes or no in terms of words you're writing, which is something referred to as classification. Okay, categorical data. Now coming to this part, under regression, taking some examples, grade prediction is one example, and then house price prediction is one example. Let's say, for example, given the house size in square feet, okay, given the number of rooms in a house, okay, you try to predict what is the house price, which is always in numeric, isn't it? Which is always in numeric. That could be taken as one of the example for what? The regression analysis. Also the sales predictions. What might be the sales after this post-lockdown? That might be the analysis which is going to be performed by these e-commerce websites. Okay, so they may see some good sales after this post-lockdown. Okay, so in that way, they're trying to analyze the sales which is always in numerical format. So some of the examples are like this. Stock market analysis is one of the examples for regression task. Okay, coming to this classification part, medical imaging is one of the examples. So we are given this chest X-ray of this COVID-19 patients. After performing this medical image processing, you either say that this person is positive COVID-19 patient, this person is negative COVID-19 patients, having bought the X-ray images, chest X-ray images, which is one of the examples for classification. Either you say that it is positive or negative. Customer will buy or not is also one of the example as we took in the earlier this thing. Now coming to this part, what are some of the algorithms that we always see in this continuous target data or regression or doing all these kinds of tasks like grade predictions, house price predictions, and sales predictions? The algorithms like linear regression, very fundamental linear regressions, which we also look into linear regression, and also we have this neural networks. Okay, and then again we have this different forms of linear regressions, multiple linear regressions, and then we also have this decision tree regressor. Okay, support vector machine with a regressor. Okay, random forest regressor. There are different kinds of algorithms. For instance, I have taken only two examples here. Very fundamental one is linear regression, and then the other one is the network, neural network. Okay, that's fine. Now coming to this job part, some of the algorithms for categorical data is logistic regression, which is completely based on this linear regression. Remember that these are some of the interview questions that always be asked in the data science interview. Interviewer will definitely ask you what are the different tasks in machine learning. Give me some examples for machine learning algorithms that usually work with this continuous data and categorical data. Okay. To learn this, categorical data, we have this logistic regression, support vector machine, and Navi-based algorithm, and then decision trees based on categorical data, which is something that we use for categorical data, and we call it as the classification job, which is again very important. Okay, I told you that the algorithms that could be SVM and then DTs, decision trees. Remember that we also have DTs for continuous data, decision tree regressor, decision trees. There is difference between these two that everybody has to remember. So in the interview, a question will always be raised that do we have this decision tree algorithm for continuous data? Your answer must be what? Yes, because we have this decision tree regressor. Okay, that is also one of the example that you can consider. So here I've taken only few examples, for instance. Now coming to the right part of your slide, we have this unsupervised ML. Okay, target variable is not available. It means that the target data itself is not available. The output itself is not available. You have given the data. You need to perform some discovery task, data discovery task. Okay, where we do not have this output itself. In that cases, we go with two kinds of categories. One is clustering, one is association, which is very important here. Clustering means what? Okay, customer segmentation is also one of the example for this clustering. Grouping similar kinds of data. What is this customer segmentation? Let's take a simple example that based on the buying patterns of customer, okay, based on the age group of the customer, Flipkart or Amazon is trying to group the things. Let us take an example that chances of buying this iPhone mobile phones are by persons between the age 20 to 30, and they are also getting really good salary. They are working really hard. Therefore, we group all those people in one category. Chances of buying this, novels could be from age between 40 to 50 years. Okay, so that you can group it as one customer cluster. In that way, we try to group them based on their ages and their buying interest. Okay, coming to this document clustering, which is also very important. Remember that if I try to search something about ATME College of Engineering, there might be different ATME College of Engineering. There might be different information available on Google about this ATME College of Engineering. When you type this ATME College of Engineering, you get different links, isn't it? When you get different links, You only get information which is having this, what? Information regarding this ATME College of Engineering. The Google is actually picking up that keyword and then trying to group or cluster the things. Okay. So if it is clustering the things, it means that it is something referred to as document clustering. Grouping similar kinds of documents based on a keyword is referred to as what? The document clustering. Okay. Now, taking some example for that, K-means is one of the example, and density-based scanning algorithm is also one of the examples. We also have other kinds of clustering algorithms like hierarchical clustering, agglomerative hierarchical clusterings. Different kinds of clusterings algorithms are there. For instance, I have taken these two algorithms that you can consider to perform this clustering. Okay, now coming to this association part, which is that you people have learned probably in your data mining subject, that you try to go with this market basket analysis. What is this market basket analysis? So say for example, you go to any, a grocery stores or Reliance Fresh Market, okay, Big Bazaar, you see that the products are arranged in a particular order. You try to buy some milk product. Say for example, you purchase or buy this milk product, and then beside that you also see the butter, and beside that you also see the ghee. It means that the products are arranged in such a way that when customer purchases this milk, then he might also purchase this other byproducts of milk, thereby increasing the profitability of the company. This is something referred to as market basket analysis, one of the typical example for what this association algorithms. Taking an example, we have this a priori, equilat, FP growth, frequent path, pattern growth algorithms. Some of the algorithms that you can consider for association. It means that you're not given the data, given target data, but you are given this only this input variables. Then you'll have to come up with some, discovery. Try to find the hidden patterns in that particular data. So this is all about what? The machine learning types that everybody has to remember, starting with the supervised ML, unsupervised ML, and then you go with categorize the things based on the kind of data you're actually working on. Getting my point? Okay. Now the next one is machine learning process, which is again a very important job here. What is this machine learning process? We are still in the fourth step. Remember that we are still in the fourth step. Now we look into this machine learning process. Now what we see that all these different tasks or different fields are having a relationship. You start acquire data from sources. You try to grab the data from the data source, could be DBMS, from the DBMS, and then once you're done with, you're set to be, acquiring the data or something referred to as data acquisition. Okay. And then once you're done with the data acquisition, remember that we also did the same job in the second step of your data science workflow, which is data cleaning, that we also do it in machine learning. It means that the machine learning is an integral part of this data science. You perform some data cleaning operations. Once you're done with that, remember that we will have to divide this data into two parts. One is the trained data, one is the test part. Trained part and the test part. Okay. So you're dividing this data. Trained part is used to train the model or an algorithm. Remember that you may use any algorithms like linear regression, logistic regression, or decision trees. To that algorithm, you'll have to feed this trained data. So taking an example that, let's remember that you have 100 records of COVID-19 patients. So generally speaking, in that 100 records, 50 are, positive patients and 50 are negative ones. In that cases, you will have to shuffle it, and then you'll have to feed 70 to 80% of training data out of that 100 records to the model, and then remaining 20% you'll have to keep it as the test data. Remember that it is not that you'll have to keep 80-20 or 70-30. It is up to you that you may divide the data. Okay, anyhow, I've divided this data into two parts. One is the trained part and the test part. The trained part goes into what? The trained model. Model is nothing but the algorithm. Okay, we also have this test data. Now, where do we feed this test data? Which is something referred to as unseen data. Nobody has seen the data. The algorithm has never seen the data. It is a new kind of data. A new person with some symptoms has approached me. then that data is given to my algorithm. Now algorithm, after learning through that data or experiences, that algorithm should say that this patient is a positive patient or a negative patient. Okay, how we are actually evaluating that? By giving this test data. Okay, this is something referred to as evaluating the model. Okay, once you evaluate the model, you may see some correct predictions or wrong predictions. Sometimes a positive COVID-19 patient might get predicted as negative patient predicted as positive patient. Okay, now your algorithm is not actually really working fine. In that cases, go back to your model and try to adjust the parameters. What is that adjusting the parameters? Maybe you try to use some different methods, dividing this, the train and the test part, more train part and the less test part, and then the 50-50%, 70-30%, and then we also have the other parameters to be tuned in the context of programming that everybody has to remember. Okay, so in that cases, you go back to your algorithm and try to tune your model in such a way that in future it will predict the right output. Okay, once you're done with that, you feel that okay, you're fine, your algorithm is doing correct job, and finally what is the next job? See, you try to deploy the model. You try to deploy the model, it means that you let the people start using that model. This is something referred to as machine learning model deployment. We started with data acquisition, data cleaning, and then train the test part, and then train the model with the training data, and then we also evaluated the model, and then finally we have deployed this model for the public usage. Okay, now people can go ahead and start using this model, machine learning model. I don't know what is the kind of algorithm you have used, but generally speaking, I call it as the model. Okay, this is something referred to as supervised learning till now. Now we have something called as unsupervised learning. Now, I told you that in the unsupervised learning, we have this input data, but we doesn't have this output data. It means that as usual, you'll have to collect the data, you'll have to clean the data, you take the train part, okay, only train part, and then train the model and then evaluate the data. Okay, if anything goes wrong, go back and try to tune up the model parameters and then finally deploy the model. Try to find the hidden parameters in your data, something referred to as clustering, customers, similar group of customers, document clustering kind of examples that you can consider for this, which is something referred to as the unsupervised learning. Okay, I think we are done with this machine learning, the basic idea of machine learning. We started with this machine learning. What is a machine learning? We also know that machine learning is a subset of artificial intelligence. And then as and when the technologies are getting changed, the terminologies are also getting changed. Okay, now we also seen the different machine learning types, and the very important part is machine learning process, supervised and unsupervised. Okay, the next part is, we're still in the fourth step. Go back to your fourth step now. I'm back to my fourth step of data science workflow now. Can you see this here? So this is a data science workflow, which is something you will have to have some machine learning algorithms. Start applying some machine learning algorithms. We're still in the fourth step now. As a very simple example, for my data of students, I'm considering this linear regression algorithm. Okay, linear regression is basically statistical concept, okay, which will always try to plot a straight line for the observations. Okay, we also got to know that there is some positive correlation between the two variables, which is number of hours you study and the grade you get. This is something referred to as correlation. In the interviews, a question will always be asked, what is the difference between correlation and regression? We'll see that. What is that correlation and regression now? Correlation is all about plotting the points and seeing that how closely the two variables are related to each other. Okay, we're done with correlation now, plotting the scatter plot. Okay, now coming to this part, a very fundamental algorithm, as I told you that, for continuous data, because we are taking example of continuous data here. We have two kinds of regression here. Remember that, univariate and then simple regression, also called as simple regression, with only one X, and then multivariate and then multiple regression with multiple X. What is that univariate and multivariate or multiple regression? Now coming to this X part, X, I told you that number of hours you studied, because we only have one variable. On the Y side, we only have this grade. Remember that the student grade does not only depend on this number of hours you study, but there could be multiple x where the grade depends on. Okay, your x can be now called as the independent variable, also called as predictors. Now y can be called as the dependent variable, the target concept. Y is nothing but the target concept. Now, number of hours you study is univariate because we are considering only one x here, x variable. In the same way, I may also go with the other variable, which could be, that could be, say, for example, the place you stay, the shelter, and the any previous coaching that you have obtained before you actually get into any degree courses or post-graduation degree courses. All these different variables does affect this y variable. As a very simple example of considering only one x and only one y. As and when the number of x increases, it is very difficult to represent in the form of a graph because it becomes multidimensional. Getting my point? Now, as I told you that linear regression is all about a straight line. Remember your high school mathematics. We have this y is equal to mx plus c. Okay, there are different ways of representing this linear regression. Y is equal to beta naught plus beta 1 into x. Now, what is this y actually? Y is a dependent variable, x is an independent variable, and then m is nothing but coefficient of x, which is nothing but slope. You should remember that. You should know how to calculate this slope, and then this c, which is y-intercept. A line which is actually cutting the y-axis, nothing but y-intercept. Now, if you consider this equation, in the future, we'll be considering this y is equal to beta naught plus beta 1 into x. Beta naught is nothing but your c, and then beta 1 is nothing but your m. Different ways to represent it. Okay, so ax plus b, or ab plus b, something like that. We have different kinds of representation for this. But anyhow, I'll be considering y is equal to beta naught plus beta 1 into x. Okay, that's fine enough. So now we'll try to plot the graph, linear regression for the data that I have considered. Okay, now coming to this part. Now what is that graph? Okay, this is a graph, isn't it? I've taken some example here. You can take different example here. The example one is prediction of grade y. Y is nothing but grade given hours studied. Okay, let's say that a student is studying for 15 hours. So how much you can get? What is the grade he can get for studying 15 hours a week? A student who studies for 12.5 hours a week, what is the grade he might get? To see that, we'll try to plot a best fitting line. Remember that I told you that regression is nothing but a straight line that we are actually trying to plot. Okay, let us try to plot this line now. Now we have this first line, yellow line, as you can see. Okay, now as you can see in this graph, once you plot this line, this becomes a regression. Regression says that depending on the y value, what is the x value? People do confuse with this correlation and regression. Do not get confused with the two terms. Okay, now once you plot a line, then it becomes what? The regression. I may go with different best fitting line. Okay, let us take this first line now. You see this first line now. As you can see, this is a line that my linear regression machine learning algorithm is trying to plot. Now once you see that, these are the observed data or the data points or the students. Blue points are nothing but your students. Okay, as you can see here, the points on the line are the predicted one. The points on the line are the predicted one. We see that there is the large distance between the student, the actual point, and the predicted point here. So, okay, here is a predicted point. Okay, and this is a actual point. This is a predicted point, actual point. This is a predicted point. Similarly, okay, there is a very negligible difference between these 2 points, the blue point and the point on the line. Okay, the point and the point. There is a distance. Now, how do you choose this line actually? Best fitting line. We refer to as best fitting line. Now, always remember that the best fitting line should be something like choose beta naught plus beta 1 such that the vertical distance between the actual point and the prediction must be less. What does that mean actually? Beta naught and then beta 1. Beta 1 is nothing but coefficient of a x. What is this x here? X is nothing but number of hours studied. Beta 1 is nothing but your slope. And then beta naught is nothing but the line which is cutting your x-axis, y-intercept. You'll have to find a line or plot a line such a way that the vertical distance between this actual point, okay, and the predicted point on the line. But as I observe this line, no, this does not seems to be a really good line. Let me go with another line now. Okay, let me try to plot. Okay, let me go with this line now. I've taken one more line now. As you can see, the point on the line, okay, line and the observed point or the student, actual student, okay, it is also showing some differences. Even here, if you extend this, yes, even here, and then even here, even here. The thing is, you'll have to plot a best fitting line such a way that distance between the 2 points must be always less. Now coming to this, yes, even this is actually showing some differences here. Let me go with the different iterations, try to plot such a way that vertical distances is always less. Okay, now I go with this one. The next line, the third line. As you can see here, I have plotted this line. Compared to other previous two lines, I see very small distances between this actual point and the point on the line, actual point and the point on the line. But here in this case, yes, remember that Adarsh, I told you that he is a smarty pant because he was studying for 10 hours and he was getting 96 marks. All these points are very close to this line, whereas this point, okay, the smarty pant Adarsh was scoring 96, studying only for 10 hours. It goes away from all these points, away from this straight line, best fitting line. Okay, now you'll have to have the line, the best fitting line. The best fitting line is also called as a model in such a way that the distance between these points and the points must be always less. But this is an exceptional case that we'll have to consider. Now, if you say that it is an exceptional case, what is that exceptional case? Remember, exceptional case is nothing but the outlier. Now, how do you in the interview, a question will always be asked something like, how do you predict the outliers? How do you analyze these outliers? There are different ways to analyze these outliers, but after plotting this best fitting line or the model regression line, we say that the distance between this point and this point is large. Okay, then you can consider this point as an outlier. You need to have some mechanism to handle these outliers. Okay, now after this, I say that, okay, this is my line. I'll remove that all the previous lines. I say that this is a best fitting line or a best model as per my plotting. Once you're done with that, the next phase is that how do you actually say that whether your model is actually a really good model or not a good model? In that cases, we have some evaluation metrics or something referred to as cost function in linear regression. The very first one is you can have different cost function. So could be the mean square error, which is something referred to as MSE, mean absolute error, MAE, and then R2, R squared. It is also called as R squared. So as an example, I'm considering this mean square error. Okay, what is this mean square error? As you can see in this, what is it? The slide, I've taken this example, the formula here. MSE is always equal to 1 by n. Summation I is equal to 1 to n. It means that n is nothing but number of observations. How many observations do we have here? We have 7 observations. And then summation yi minus yi hat the whole square. So what does it mean actually? Yi is nothing but the actual point. Yi hat is nothing but the point on the line. Okay. So this is the point on the line. So the point on the line and the actual point. Okay. Now, now this is something referred to as y hat. Okay. That is a predicted one. Now, this MSc always says that evaluation, you will have to evaluate a model. MSc always says that if the MSc value after going with this problem is less, then your model is always a really good model or a better model, best fitting line. Otherwise, it is a worst line. Okay. Now, I'll try to calculate the distance, try to calculate the MSc for this particular line of. Okay. As you can see, I've done with this MSc. So this is summation nothing but you'll have to subtract this yi minus yi hat the whole square plus 69. Similarly, do it for all other points. The point, actual point minus the obtained point. So whole square, why you're actually performing the squaring? Just to eliminate this negative values. Finally, I got to see that 472 divided by 7. So divided by 7 is nothing but n is nothing but the observations. If you see that 472 divided by 7 is nothing but 67. I don't know that whether this line is a best fitting line or not. You may come up with different regression line or a best fitting line or a model in any way interchangeably used. Once you see this MSC value, if it is very low, then you declare that model as a really good model. Okay, that everybody has to remember. Mean square error. Okay, now what is this mean absolute error? This is again a very important interview questions in there. I know data science interviews. Remember that. What is the difference between this mean square error and mean absolute error? There are different evaluation metrics here. As you can see here, so there is, when you consider this, say for example, this one, 75 minus 96, the whole square. So the value is always high, 441. The error, when it is squared, you get 441, which is always high. It means that mean square error, okay, adds more value to this. What is it? The errors. It means that it is having more weights to this error. So which is not, sometimes not entertained. Because if you're least bothered about this mean square error or the errors, something referred to as something like that, then you can go ahead and use this MSC. But we also have this MAE, which performs really well over this MSC. Okay, what does it mean absolute error? Okay, now we can also use this mean absolute error, okay, which is something like this. Before that, we are done with the fourth step now, okay, which is applying the techniques. We will try to find the insight. What is that insight now? The fifth step of your data science workflow. What is that insight? If I study more, will I get a high grade? That was our first question in a workflow. Yes, there is a positive correlation between the number of hours you study and the grade you will get. As the number of hours increases, the grade also increases. There is a positive correlation. I agree with that. Specifically, okay, the relationship is grade is equal to 65 plus 1.5 hours into 1.5 into hours. Now, what is this 65 here? 65 here is nothing but your, what is it? Y-intercept, and then 1.5 is nothing but your slope, beta naught and beta 1 index. So you'll have to know, as a learned in the high school, you'll have to know how to calculate this slope value. Okay. Now, as you took an example here, as you can see, 65, the line is actually getting this y-axis at 65, and then once you calculate this m value, the slope value, we will get 1.5, and then x is nothing but hours. This is a model that we have finally obtained. After obtaining this model, now as I observed that there is an outlier, which is nothing but if you're studying for 10 hours and then is getting 96 marks. But the actual thing is something like this. If you study 10 hours, according to my model or best fitting line or a regression line, you can expect to get an 76, but you are actually getting 96. As you can see in this figure, yes, if you're studying for, what is it, 10 hours, you might go straight and then you'll get around 76 or 77 approximately, right? So, but here it is showing this 96, which cannot be accepted, which is an outlier. Okay, now this is a model, final model that I have obtained here. Now, however, Adarsh is a smarty pants and is inflating the grade estimate. He's actually inflating the grade estimate that is out of group of points. Okay, so you probably get less than or slightly less than 80 marks. Okay, this is how we actually try to best fit a line and try to derive a model which is a linear regression model. Okay, given any number of hours, say for example, you study for 5.5 hours, substitute that value in this hours part and try to get 65 plus 1.5 into 5.5 hours, and you try to predict how much, what is the grade that a student will get if he's studying for 5.5 hours in a week. Right? That's all about what? Sharing the insights. We are done with the workflow. Yes, we started with what? The question, and then we prepared the data, and then we actually did some EDA by scatter plot, and then we also went to something called as applied techniques. Nothing but we also looked into what? The machine learning algorithms. We also looked into supervised and unsupervised. Supervised is nothing but the regression concept here. And then we also tried, bringing that best fitting line, which is also referred to as regression model. And we also predicted that, okay, this is what you will get if you're studying for 10 hours according to your model. But there is an outlier which says that studying for 10 hours, you're getting 96 marks. And we also discussed what is MSC. MSC always says that if the value of MSC is very less, then your model is really good model. That's fine enough. Anyhow, so there is alternative to this MSC, which happens to be MAE, mean absolute error, which is really good compared to this mean square error. What is that mean square error? As we know that for the larger errors, we were squaring it, we were getting really big values. But to avoid that penalties, okay, we go for this mean absolute error. Okay, it says that, so both are loss metrics. Mean absolute error is loss metrics if the value of, what is it, MAE is lesser, better the model. As you can see in the figure here, so it is 1 by n, summation j is equal to 1 to n, yi minus yi add. And you're taking absolute because you're trying to eliminate what? The negative values here. Okay. Now, the last one is what? In the interviews, a question will always be asked, something like this. So, what is the difference between MBE, MAE, and MSC? You'll have to say that, okay. What is the advantage of MAE over MSC? Right. Okay, next very important statistical measure is R square or R squared here. Okay. Now, R squared measures how well a regression model, okay, the best fit line predicts the targets. When you're done with the best fitting line or a model, okay, the R squared will always lie in between 0 and 1. If it is above 0.5, then your model is a really good model and it is predicting the right output. If it is below 0.5, then your model is a worst model. It is actually predicting the wrong ones. Okay, I'll not go in depth of R squared because R squared is again a different this thing. Okay, so it takes a different concept. Okay, where we'll have to discuss the different R squared measures. But I'm leaving a link here where once I share this content, so you will have to, you can look into this link and then you can see what are the differences or relationship between this MSC, MAE, and then R squared. Remember, MSC and MAE are nothing but loss metrics. R2 is nothing but it says that the goodness of your model. Okay, that is all about what the metrics for linear regression. We are done with what? The supervised one. Under supervised one, we have regression and then classification. Now it is time to look into what? The classification concept here. Okay, now what is this classification concept? As I told you that whether a customer will a product or will not buy a product. A patient or a person is having infection, COVID-19 infections, or it does not have this COVID-19 infections, positive or negative infections. Okay, now we'll straight away jump into this classification, which is a supervised learning, which happens to be your what? Your logistic regression. Remember that I told you that in the earlier slides, logistic regression is always based on this linear regression. Remember the point. Now we'll take a problem, we'll try to solve a problem in linear regression, and we'll try to say that linear regression cannot solve this problem. That is why we are going with this logistic regression. What is that problem? We know that it is a classification problem. Classification could be 0 or 1, true or S. Okay. So it is always a probability problem. Okay, logistic regression is always a probability problem, which happens to be either 0 or 1 in the context of binary classification. Okay. Now classify either true or false, spam or ham, buy or not buy a product. Whenever you receive any emails, we know that some emails go to this spam folder and then many emails go to these inboxes. How this Gmail is actually trying to predict whether this email is a spam email or this ham email. Ham is nothing but the good mail, the spam is nothing but the spam mail. Okay. Now coming to this, it is nothing but a classification problem that can also be taken as one of the example. But here in this case, okay, I would like to take this probability of getting infected given age. What is that actually? We are given the age actually, okay, given the person age, only one value I'm considering. What is the probability of getting infected is a problem that I'm considering. This is a probability problem. As you can see here, okay, this is a graph that I'm going to consider, one of the example. Okay, beta naught and beta 1 is actually trying to increase and decrease. We are going with different iterations. We are actually trying to get a kind of curve called S curve. We'll see that. What is that S curve? Okay, now trying to solve the problem. This is a linear logistic regression problem, but we are trying to solve using linear regression because logistic regression is based on linear regression. Okay, now the problem is given something like this. Age is between 20 and 55. Okay, given the age, what is the probability of getting infected with this COVID-19 disease? Now, remember that I've given some age here. You'll have to note this point. P is nothing but the probability. It has to be between 0 and 1. We have a straight line here. Y is equal to beta naught plus beta 1 into x1, which is nothing but your linear regression. Let us take a first case now. Beta naught is nothing but y-intercept minus 1.70. Randomly, I'm picking some value just to analyze the things. Beta 1 is nothing but 0.064 and the age is nothing but 35. Okay, so picked up some age which is 35. Probability of getting infected, okay, which is y of p is equal to 1 and the age, which is equal to substituting these values beta naught and beta 1 in the straight line equations, I would get 0.54. It means that there are 50% of chances where a person can be infected if the age is above 50. That's fine. Okay, this is fine. Now we'll go into this other ages now. For age 25 and 45, I'm considering this one. Y is equal to p is equal to 1 and the age minus 1.700 plus 0.064 and substitute this age value. Once you substitute this age value, you are actually getting minus 0.09, and once you substitute this 45, you're getting 1.20. But remember, this logistic regression is basically the classification problem because it is based on probability. Either it could be 0 or 1. But as you can see the values here, it is going below 0, minus 0.09. It is going above 1, which cannot be entertained here. It means that you'll have to bring those values. If it is minus 0.09, bring that to 0. If it is above 1, bring it to below 1 or 1, something like that. Okay, now we shall try to plot a graph now for this data. Okay, for this data that we have considered here. Now, once you plot this graph, this is a graph that you actually obtain. Can you see this here? It is going below 0 and then it is going above 1. We have 0 and then 1 here. Okay, X is nothing but age and then infection is nothing but Y. But we'll have to try to overcome this problem. We'll have to bring that into, below this 1 and then to 0. Okay. Now we have solved this problem using the linear regression. Basically, this is a logistic regression or a classification problem. Trying to solve that using linear regression, we happen to see that it is going above 1 and then below 0. Okay, now there's a problem with this linear regression. Now it is time to look into what? The logistic regression. Remember that logistic regression should be proved. It is based on linear regression. Now, how we are actually trying to prove that? We shall try to bring those values between 0 and 1. Okay, now coming to this part. Now, as I told you that the value should always be greater than 0. It should not be a negative 1. Okay. So remember, a simple mathematics, if you want any value to be positive 1, either you go for the squaring operation, the absolute operations, or the exponent kind of operations. So for that, what I'm considering the same linear regression equation here, which happens to be beta naught plus beta 1 into x. I'm taking exponent value for that, exponentiation of beta naught plus beta 1 into x. Thereby we say that it is always positive. It is always greater than 0. Now coming to this part now, for p less than or equal to 1. For p less than or equal to 1, it has to be always less than or equal to 1, as I told you that. Now for that, what I'm trying to do is some engineering work I'm doing here. So probability of x is equal to, take this exponent of beta naught plus beta 1 into x, divided by 1 plus exponent of beta naught plus beta 1 into x. Whenever you divide this numerator by one number greater than that, then obviously the number is always less than 1. Trying to bring that value below 1 or to 1. Okay, now doing some simple mathematical operations here. So bring this value to your left hand side. It becomes probability of x into 1 plus exponent of beta naught plus beta 1 into x, which is equal to exponent of beta naught plus beta 1 into x. And then you try to bring this to your right hand side. It becomes exponent of beta naught plus beta 1 into x minus probability of x into exponent of beta 1 into beta naught plus beta 1 into x. And finally, taking this 1 minus probability of x common out of this, you get 1 minus p of x exponent of beta naught plus beta 1 into x. Thereby, taking this 1 minus p of x to your left hand side, you get p of x divided by 1 minus p of x, which is equal to exponent of beta naught plus beta 1 into x. Now, remember that this particular equation on your left hand side said to be the logit function. Logit function. Therefore, we call this algorithm as what? Logistic regression. So we tried to solve that. Okay, it is based on linear regression. Okay, and then we also said that it is having a term logistic. Now, why the term logistic? Because it is having logit function. Logit function says that probability of happening an event by divided by not happening. Okay, p of x nothing but event happening, 1 minus p of x not happening. Okay, which is equal to exponent of beta naught plus beta 1 into x. That's fine. Now we'll have to eliminate this exponent. To eliminate this exponent, take a simple mathematics, take a natural logarithm on both sides. I would like to take this natural logarithm, and then we know that logarithm and exponent are always opposite to each other. Thereby I get that natural logarithm of p by 1 by minus p, which is equal to beta naught plus beta 1 into x. As you can see in the right hand side, this particular algorithm is completely based on this linear regression because both right hand side are same, beta naught plus beta 1 into x. So therefore we say that which is equal to what? Y is equal to beta naught plus beta 1 into x. Now, logistic regression, which is a classification problem, we tried solving using that linear regression, which was not possible because the value was going below 0 and then above 1. We tried to bring those values between the 0 and 1. Thereby, we took this exponent operations, and then finally, we showed that there is something called as logit function. Logit function says that probability of event happening, not happening in the context of statistics. Okay, now that's fine. Now we try to plot the graph now. Okay. Ready to plot the graph now. Okay, we tried chopping off that line which was above, going above 1 and then below 0, and then we tried to bring those lines on 1 and then 0. As you can see here, this is in the shape of S. It is also referred to as S curve, also called as sigmoid curve in logistic regression. People have learned, see, this is a very important thing. In the interview questions, they'll be asking you, how do you say that logistic regression is based on linear regression? Give me an example for that. In that cases, you will have to have this knowledge. Take an example, try to solve that using this linear regression and say that this is not possible using linear regression. Therefore, we go with this logistic regression. And also they will ask, what is this logistic term in logistic regression? Then in that case, you should be able to in a position that what is this logit function? Okay, as you can see this S curve, this is also called as S curve or sigmoid curve in the context of what is it? Logistic regression. Now we have this final equation for logistic regression. Okay, whereas linear regression was just a simple straight line, y is equal to beta naught plus beta 1 into x, 1, whereas logistic regression has taken different shape here. Probability of x is equal to exponent of beta naught plus beta 1 into x divided by 1 plus exponent of beta 1 into beta 1x. Okay, this is the final equation. So trying to divide the numerator and denominator by exponent of beta naught plus beta 1 into x, you would get 1 by 1 plus exponent of minus beta naught plus beta 1 into x. So substituting this or equating this minus beta naught plus beta 1 into x with this z value, the final equation is something referred to as sigmoid equation, which happens to be p of x is equal to 1 by 1 plus exponent of minus z. Remember that this is also basis for your advanced concepts like neural network, because in the neural network, we are also going to make use of this sigmoid equations. Why sigmoid equations? Why it is required to use the sigmoid equations? And then what is the advantage of the sigmoid equations over other activation function? This is also something referred to as activation functions in the context of linear, neural network that everybody has to know. Okay, we're done with this logistic regression. We also proved that, okay, given the age, so what is the probability of getting infected, whether it is a positive one or a negative one, something like that. Okay, now it is time to evaluate a model now. We did completed this linear regression evaluation, but it is very important to learn this evaluating this classification algorithms. So there are some of the metrics that everybody has to remember here. The key classification metrics we need to understand are accuracy, recall, precision, and FN score. and we shall try to understand each one of them. Remember, in the interviews also, so no direct questions will be posed something like, what is the accuracy, what is the recall, what is the precision, what is the F1 score. But remember that why we are going with the recall when we have this accuracy, why we are going with this precision when we have this accuracy, why we are going with this F1 score when we have this accuracy. That is the kind of questions which is always asked in the interview that everybody has to know. Let us take a very simple example now to understand this classification metrics now. Okay, now taking an example, this is all we have done now. Okay, now as a very simple example, you can be given with different kinds of classification problem, COVID-19 example, or given an image, okay, dog image, classifying that as a dog, or given a cat image, classifying that as a cat. Okay, if the dog is classified as a dog, then you are making correct predictions. If dog is being predicted as cat, then you are making a wrong predictions. It means that your model is actually making a wrong predictions. If cat is being predicted as cat, then it is a correct predictions. If cat is predicted as wrong prediction or dog, then it is a wrong predictions. As you can see here, we have a classifier. I may use this logistic regression or neural network concept or this Naive Bayes algorithm. That could be any algorithm for that matter. But what we are trying to say here, so we have this image here, which is something referred to as test image. Given the test image to the trained model, then you come up with the output which either says that it is a dog or a cat. Okay, now the correct label of this image is dog. Yes, it is a dog. Okay, now if that model or your model is predicting it as a dog, then dog is equal to dog, then you are making the correct predictions, then the accuracy is always high. Fine. Now next scenario is what? We go with something like this. Now, given the dog image, if it is being predicted as cat, then you're not making the right predictions, then accuracy falls down. But anyhow, we go a little in depth about this accuracy and then recall. We try to understand by taking this COVID-19 example only, right? Now, coming to this, what is the accuracy now? Accuracy in classification problem is the number of correct predictions made by the model divided by the total number of predictions. It means that, so correct predictions divided by total number of predictions. Either it could be correct predictions or wrong predictions. If you're doing that, then obviously then your model is having a really good accuracy. Now coming to this point, let us say that you have 100 records. Out of that 100 records, your model has predicted 70% of the record rightly, nothing but right predictions. If that is the case, your model is having 70% of accuracy. If it is predicting 80 records correctly, then you say that 80% of accuracy, something like that. Okay, what is that? Number of correct predictions divided by total number of predictions is your accuracy formula that everybody has to remember. But there is always a problem with this accuracy. You know that why we're going with this recall and then the other measures. Let's say that there is something called as imbalance classification that everybody has to know. We take different advanced approaches in data science, but for now, let us try to understand the imbalance classification. What is that imbalance classification? Now, accuracy, generally speaking, does not go well with this unbalanced classes. Now, say, for example, you have 100 records of COVID-19 patients. Out of that, you have 90 records of negative COVID-19 patients and 10 records of positive COVID-19 patients. We have 90 records of negative and then 10 records of positive. Now, whenever a new data is given, a person approaches me and he is having kind of symptoms, and if I give that input to my algorithm, the algorithm will always say that is a negative patient, though is actually positive one. Why? Because your accuracy fails there. Okay, because you doesn't have the equal number of classes, which is something referred to as imbalanced classification that everybody has to overcome. Okay, now how do you overcome this accuracy problem or the imbalance classification problem? Now, to overcome that, we have this recall and then precisions. Combining recall and precisions, we have something called as F measure. Okay, that's fine now. Anyhow, now let's say that if a person approaches you and then actually is a positive patient, but model has predicted is a negative patient, then the problem is always high. He may go to the people, he may meet his friends or to the public places, and he can start spreading the disease. Okay, that is one point that everybody has to remember. Okay, that is where we actually fail. Now we'll try to take some example. Now we'll try to analyze what is actually happening. Okay, which is very important one. Now, as you can see here, I've taken different COVID-19 cases here. So this is an actual case, the positive case. And then this is a model predicted one. Model says that positive patient is positive. That's correct. If a model is predicting positive patient as a product positive, it is true positive. Remember, in the context of classification metrics or confusion metrics, we call it as true positive. Okay. Now coming to this point. So we have this positive patient, but being predicted as negative patient. Okay. Highly, dangerous. It means that he can start spreading the disease like anything. He's happy now. He doesn't have any diseases. Then he can go ahead and start spreading the diseases. So your model is saying that it is a negative patient. And then we have this negative patient being predicted as a positive patient. Okay, this is another case now. Now there is a negative patient. That negative patient is predicted as what? The positive one. Now this is okay to some extent because he may go with n number of tests. Maybe in the second test, he may be predicted as what? The negative one only. Okay, because it doesn't have the disease. That is a thing that we have here. The last one is what? It is a negative patient, and then what is it? It is also negative. Okay, so the model is correctly predicting. The first one is said to be what? The true positive. The second one is said to be what? The false negative, because the positive one is being predicted as the negative one. The third one is something about what? The negative is being predicted as the positive one. This is something referred to as what? The false positive. And then finally, negative is predicted as negative. This is something referred to as what? The true negative. As you can see in this classification or confusion metrics, this is again a very important thing that everybody has to remember now in the exam, in the interviews. So this is a question that always be asked. Okay. Now we have this. What is the confusion metrics? What is true positive? Give me an example. False positive, give me an example. This false positive is type 2 error. The false negative is type 2 error, and then false positive is type 1 error. As you can see here, this is a true condition. This is a predicted condition. Nothing but your model is predicting these labels, and the actual condition is this. Positive, it is true positive. Positive, predicted as negative, it is false negative. And then negative, it is positive, it is false positive. Negative, it is true negative. You're done with the confusion metrics. Okay. So the thing is, your model may say that it is a positive or negative, but after evaluating this model, you get to know that, okay, your model is a really good model or not. Okay. Now, finally, as I told you that we have this recall and F measure. What is it? Precisions. We'll see that now. Now, to handle this kind of error, accuracy does not handle this. What is it? The false negatives, particularly, and false positives. Okay. So type 1 and type 2 error is not actually handled by your accuracy measure. That is the only reason we go for this recall and then precisions. As you can see here in the precisions, we are considering true positives divided by true positives divided by false positive. As I told you that your accuracy does not handle this kind of error, false positive. That is the only reason to go for this precisions. And then finally we have this recall. Recalls handles false negative. We have this true positive divided by true positive plus false negative. So that is the only reason we go for this accuracy and precisions. Later we have something called as what? Combining these two. F measure provides a way to combine precision and recall into a single measure that captures both properties, which happens to be 2 into precision into recall divided by precision plus recall. That happens to be our F measure. Remember that whenever you done with the classification modeling, you always go with this evaluation metrics. Then you see all these matrices, particularly in the context of imbalance classes. Recall, precisions does play a very important role in order to know whether your model is a really good model or a bad model. Okay, that's all about what the classification and then classification metrics is. The next part is what? We are done with the supervised learning part. Let us concentrate on unsupervised learning part, which happens to be your one of the example that I'm considering is k-means algorithm. I took an example that grouping these customers based on their purchasing patterns, okay, based on their age, based on the salary, and then bringing or clustering those customers or documents based on their keywords are also one of the examples for what is it? The unsupervised ML. You're not given with what? The target label that everybody has to remember. Target label is also called as what? The output. Now, as I take one of the example, I'm considering this k means. Okay, k is nothing but number of examples. Means is nothing but the average or centroid that everybody has to remember. As you can see in this, the GIF that I have considered here, we have taken the different set of points here, I'm not going to this algorithm here, but anyhow, let us directly dive into this algorithm, which is nothing but we have set of points, blue points, and then red points, and then green points. And also we have star, which is actually moving here. Okay, from one place to another place. Why that star is actually moving? Remember, initially you will have to pick one point as a centroid. Okay, once you pick that point as a centroid, the points which are closest to that centroid for all the three different points gets clustered together. As you can see here, the star is actually moving, and then the points which are actually close to that star is actually getting clustered with that star. Red cluster, and then blue cluster, and then we have this green cluster. It means what? So once you're done with that clustering, first iteration, second iteration, for every iterations we try to compute the mean, and then we try to move this star from one point to another point. So why this star is actually moving? Because you're actually calculating the centroid or a mean for the newly formed cluster, and the cluster is actually moving from one place to another place, thereby finally clustering those similar points. Okay, and k is nothing but what is it? The number of clusters that we are considering is 3 here. K value is always 3. Now remember that how do you measure whether a point is closest to a centroid or not? We have different distance measures that everybody has to remember. We have taken this Euclidean distance. Okay, we can have this Minkowski distances. Different forms of different measures are there. You can go ahead and consider these different measures and then try to calculate the distances between the actual point and the centroid and try to cluster the similar points. Okay, so this is something referred to as the unsupervised learning, where we are not given the target label or the output label. We are only given this data. The only thing is you need to discover the hidden patterns in the data, come up with kind of concepts like clustering and then association. Okay, now we are done with this. We started with this data science task, and then data science Venn diagram, and then data science workflow. In the workflow, I took an example that you start with the data, you start with what the data preparation, and then you go ahead with the EDA, exploratory data analysis, and then the fourth step is very important because we are always very much interested what's going to happen in the future, which is always ML algorithm, which try to integrate with this data science, and then we shared the insight. Okay, finally we also looked into different ML algorithms and then different tasks in ML algorithms, and then supervised and unsupervised. Considering this last example, so you have different kinds of algorithm, you can start exploring different kinds of algorithm. The one which I'm considering is k-means. Remember, sometimes in the interview a question will always be asked, how do you actually try to come up with the k value? What is the k value? You cannot simply say that k value is 2 or 3 or 4 or 5 or 10. You may come with 100 kinds of clusters. Remember, there is something called as elbow method in data science that everybody has to remember. There is something called as elbow method. Using that elbow method, which is again advanced concept in this unsupervised machine learning algorithm, where you try to say, okay, this is the value that you will have to consider for k in the clustering algorithm. Okay, this is the value that you'll have to consider. Either it could be 5 or 6 or 7, whatever the number. It is always, judged based on this. What is it? The elbow method in unsupervised ML that everybody has to remember. Now coming to the last part, we know that data science is the most demanding jobs in the 21st century. Now you might be in the final year, you may be in the pre-final year. The thing is, you need to have all these kinds of skills. I do not say that directly you start with the linear algebra or statistics, something like that. Start with some concepts, some algorithms, try to understand what is the mathematics or the statistics behind every algorithm parallelly when you learn any concepts in data science. Okay, it is not that you'll have to first learn statistics, first learn linear algebra, and then go ahead with the data science concept. No, it is required to have this data science knowledge, all this different fields knowledge, but take a concept and start learning what's actually going behind every algorithm. Do not only get well versed with this programming concept, also you should understand what's the statistics and the mathematics, and you should also have that kind of communication skills. Say for example, somebody will come you and approach you and then they'll say that, okay, this is what I need to be predicted in the future. In that case, you come up with a model and you'll have to share some insights of that model. I told you that. So in in the grade point predictions problem, we had come up with some insights. That is nothing but what the communication that you'll have to convey it to your customers. Okay, we have different tools for that. We have Tableau and Power BI kind of softwares where we actually have this communication kind of tool where you can come up with something called as storytelling in data science. So where you come up with different communication concepts. Now to get started with this machine learning, okay, what you need to learn, as I told you, that statistics and then linear algebra, Python skills like NumPy, numerical pi, because we have so many scientific calculation in that. Pandas, we work with data, and then Matplotlib just to come up with this EDA, different kinds of graphs and graph representations. And then on top of this Matplotlib, we also have this Seaborn and then scikit-learn, particularly for this machine learning concept. On top of this scikit-learn and other things, we have this Google products, Google, what is it? Open source platforms like Keras and TensorFlow, where you can start exploring this concepts of neural network. Okay, now coming to this, one of my favorite websites or links that always refer to gain knowledge in data science is Machine Learning Mastery. Is one of the very beautiful website that you can go ahead towards data science, and then Python programming.net, Analytics Vidya, scikit-learn. I always suggest you that whenever you start learning any pandas or Matplotlib, any kind of concept, go ahead and start looking into this documentations. Do not go and then read any other kind of materials provided by somebody else. Always go with a standard one. You you will get the immense knowledge of the particular concept. Okay, and then you can start with the Kaggle. Kaggle is where you get the data. Okay, you get a number of data sets, whatever the data set you require, and then you also have practice data science problems in the Kaggle websites. Okay, we have different kernels over there. You can start it, and then to go with the certification program, remember that you may come up with hundreds and 200s of certification, but it doesn't matter. Only thing is skill remains at the end. You need to practice, come up with a different algorithm, come up with the different insights. Some may say that, okay, Adarsh is a smarty pant, but some may say that it is not he's not a smarty pant. The thing is, different people are coming up with different insights. Only thing is, you'll have to come up with the best insight possible. Okay, now it is up to you that you may go ahead with different kinds of certification. That is where you get knowledge. I agree with that, but at the same time, you should develop the skills which are very much important. Take a problem and start working on the problem, on your own. So in that way, you try to get some hands-on experience or knowledge on this data science. Okay, now how do you actually, I say that getting started with data science, scikit-learn and pandas are very important thing. And then learning this thing, Collab is one solution where when we have this huge amount of data, then you can go ahead and use this Collab and the AWS, Amazon Web Services, the Kaggle kind of software. And then how to build your data science profile, which is very important. Remember, Kaggle is actually giving so many competitions. So try to participate in that competitions and also try to explore many kind of different Kaggle problems. Contribute to the Kaggle community. And then we have a website called Medium where you get data science problems to be solved and then the concepts. Try to contribute some articles to the Medium. It may be a very simple article and could be an advanced one. Try to share or try to contribute some articles to this Medium, a quality article to this Medium. And then always remember that maintain a GitHub profile. Try to create or develop your own project and push it onto GitHub website. So once you're done with that, you can share it to your recruiter, and then you can look into that GitHub and then other profiles like Medium and then Kaggle. Quora, where you actually try to answer some of the questions. I also try to answer this stackoverflow.com, where you can become, if you are a developer, you really versed with this data science concept, you can try to answer some of the questions on Stack Overflow. Thereby, you're actually building a data science profile. Okay. So that's all about today's data science, all about data science. So you can connect me on this Gmail and then the LinkedIn profile. Okay, and then my number is this. And finally, I thank I would like to take some questions before ending this program from the participants. If there are any questions, I would like to take and answer those questions.
Thank you so much, sir. There is no questions.
raised in the chat box.
Okay.
Okay.
Right. I thank you once again to the ATME College of Engineering. Special thanks to Anil Kumar sir, Puttegora sir, Head of Computer Science and Engineering Department, and Dr. Basavaraju sir, Principal, ATME College of Engineering, for giving me this wonderful opportunity to deliver this webinar on Unlock Your Data with Data Science. So thank everyone for patience in listening to me. Thanks very much.
Okay. As we have come to an end of this session, I am Vibha, Assistant Professor, Department of Computer Science and Engineering, would like to take this opportunity to thank our today's speaker, Mr. Hemant Kumar A, Data Science Consultant, for his time and sharing his knowledge with all of us, sir. It was very informative. Thank you so much for accepting our invitation, sir. Thank you once again. I would take this opportunity to thank our management and our beloved principal, Dr. Pasivaraj L, for supporting us to conduct this webinar successfully. I would also take this opportunity to thank our HOD, Mr. Puttagowda D, for helping us out in organizing this webinar. I would also like to thank our coordinators, Mr. Anil Kumar CJSO and Mrs. Sneha MP, for successfully conducting this webinar. Lastly, I would like to thank all the professors, research scholars, and students for joining this webinar from various institutes. I hope you gain knowledge on data science. Thank you all for making this webinar successful one. Feedback link will be shared in the Telegram group. Certificate will be issued within 3 days. Thank you once again for joining us. Have a good day. Thank you so much, sir, for joining us.